Hello all, welcome to the fifth lesson of Chapter 9A, quasi-Chapter 9A. Today we're going to focus on equations of proportional relationships, and that is our target for the day. I will create an equation to represent a proportional relationship. If you need, pause, check your answers from assignment number 5. Come on back when you're ready. All right, so again, let's focus a little more intently on our learning target. We're going to identify the constant of proportionality first, look for that constant change, and then write an equation for a proportional relationship. Now, you do have notes available, so you go ahead and fill these notes out as we're talking about this. To express a proportional relationship using an equation, you must first calculate, find, or identify the constant of proportionality. Now that is a constant ratio, y versus x. Meanwhile, the equation of that relationship is always going to be in the form y equals k times x, where k, the number in front of the x, the coefficient of x, is going to be that constant. You can think of y equals 60 miles per hour as writing something like y equals 60 times the number of hours. But we have to first talk, okay, what is y and what is x? And if you have a relationship, how do you know which is which? So let's talk about that. The numerator is called the dependent variable. Now, the dependent variable is essentially the amount that you're measuring or you're looking for. For instance, when you're driving miles per hour, generally you're looking for the number of miles. Also, what's buried inside of its name, the dependent variable, is what depends on the other guy. For instance, think about driving. The number of miles that you drive depends on how many hours that you're driving for. You cannot figure out the miles until you first know how many hours. On the other hand, it's not like the hours change just because you get in a car and start driving. The hours would be what we call the independent variable, which is independent of the other guy. In other words, it doesn't change because the other guy changes. Meanwhile, while the dependent variable is what you're measuring or you're looking for, you can choose the independent variable. I can choose to drive 2 hours or 6 hours or 20 hours. So we're going to be talking about this for a good portion of the next couple weeks. Every time you're looking at variables, ask yourself, which depends on the other guy? And whenever you're graphing, and we'll talk about that later on, the dependent variable will always go on the y-axis. For instance, our example, the miles, will depend on the number of hours. All right, go ahead and make sure that's written down in your notes as we continue on with our notes page. First up, we're going to determine the relationship shown in each table. If A, it is proportional, then B, we should be able to write an equation to represent it. First thing we do is set up the ratios and identify, is it a constant ratio? Now, if I look at example A, and I'm going to make this a little bigger for now. If I look at 65 compared to 1, 130 compared to 2, 195 compared to 3, yes, in fact, those are constants. And so we have a constant of proportionality of 65. Therefore, instead of writing y equals some mystery number times x, we're going to write y equals 65 times x. Let's move on to comparing cost per pounds, whatever we're measuring cost. And so I changed not 3 to $2.25. We're comparing the cost, which depends on the number of pounds. So in this case, if I were in fact to divide all of those out, it equals or reduces to 75 cents per 1 pound. And we can use that constant of proportionality to write y equals 75 hundredths times whatever x value you choose. Now let's compare hours to miles. Gee, that sounds kind of familiar. Don't be intimidated. We already know how to divide or reduce complex fractions. 4 1/2 compared to 3/4, and naturally 9 compared to 1.5. Now it turns out when I change all of those, they will in fact reduce to 6 wholes. And therefore, basically what this is saying, 6 miles per hour, so let's write it as an equation. Y is equal to 6 times x hours, and you can choose any number of hours you want, and we'll be able to find or identify the y value. So you can look at how all these problems are similar. You can look at how they're different. Naturally, they're measuring different things. Naturally, they're different numbers. But how are they similar? Well, we try to identify first if the ratios are the same. Then if the ratios are the same, we can substitute that number in as the coefficient of the x value to find the equation that describes the same relationship. Y equals 65 miles for every x hour, y equals 75 cents for every x pound, and y equals 6 times every x hours. All right, so on the back of the notes page, we're going to start actually looking at applications of this. So go ahead and take a moment, read this on your own, please. So the very first thing we want to do is identify which is the independent variable, which is the dependent variable. In other words, what are we trying to find? Actually here, if you kind of look in the words, it will give you a hint as to what you're finding. After all, the cost depends on the number of cashews that you're buying. It's not like the cashews depends on how much money you spent. All right. When you go up to the cashier, they're going to first say, okay, how many bags of cashews, how many pounds did you buy? Then they'll be able to identify what the cost is. Now, in this case, they give us several relationships. 2 is related to $5, 3 pounds is related to $7.50, and 8 is related to 20. So the first thing you'll want to do is you'll want to set up each of those fractions, each of those ratios, I should say. Then when you reduce, and I'm going to go, since it's money, I'm going to change it to decimals. And I'm quite confident that you guys know how to divide. In this particular case, it ends up turning out to be $2.50 for each and every pound of cashews. I'm sorry, I should have written pounds there and dollars so that you actually know what those numbers mean. So how do we turn that into an equation? Well, the y cost is going to depend on or be found by multiplying $2.50 times each and every one of those pounds. All right, so step number 1, show that the relationship is number of pounds cashews is proportional. Got it. Step number 2, write an equation. Got it. Step number 3, find the cost of 10 pounds. With that in mind, all we have to do is use our equation and say, okay, $2.50 for every X. Where is the 10 going to be substituted in? Should we put the 10 in for the Y, or should we put the 10 in for the X? Naturally, if you look back at the table, you'll identify the fact that 10 is the number of pounds, and so we substitute, nope, that's not going to be what I want. Let's try that again. 10 is the number of pounds, so we substitute it in for X, and we find Y, the cost, $2.50 times 10, move that decimal point, one place value, and we get $25. All right, so again, keep coming back to what depends on what. Here, the cost depends on the cashews. So cost is Y, cashews is X. Can we find if it's proportional? Yeah, we're pretty confident with that by now. Use that constant ratio, we call it the constant of proportionality, and put it into your equation. Then you can use the equation to find any number. So imagine we could have just continued on the table, but what if it didn't say 10 pounds? What if it said 110 pounds? Who wants to continue that table? But the equation can be quite helpful. I'm gonna not say any more about that. All right, pause the video if you need, and come on back when you're ready. All right, first things first. We want to find, is this a proportional relationship? So what are we comparing? What depends on what? And when you think about it, actually they gave us a little hint in the words. But the amount of flour you need is going to depend upon how many servings or how large of a batch that you need. Now, one could argue this could go either way, and I could hear that argument. But in our particular case, we're going to choose the number of servings, how many of our friends, how many of our family members will be coming over for that big summer party we're all waiting for. All right, now that we know the servings, let's go ahead and find the cups of flour. Now they give us two different relationships here. So if you go ahead and set up those ratios. And let me come down to the bottom and let's go ahead and work those out, shall we? You know, Mr. Cowan, I like to cross reduce, make my life a little easier. All right, so there's one ratio. Let's find out if it is in fact a proportional relationship. We're going to now divide 4.5 by 18. Cross reduce by 9. And look at there. So we have now identified a proportional relationship where for each X serving, we're going to need 1/4 of a cup of flour. All right, so write an equation, check. Determine how much flour for 28 servings. So if I rewrite this equation, I'm going to ask myself, where is the 28 going to go? The 28 is the number of servings, servings being the number of X. We're going to go ahead and write times 28. Now, naturally, that's 28 wholes. I'm going to pop a 1 under there. Cross reduce to make my life a little easier, and we end up with 1 whole times 7 wholes, which is 7 whole cups. Again, here we would argue the amount of flour is dependent upon how many servings that we would like to make. All right, let's go with one more example where we're talking about money. So pause if you wish, read it on your own. So what depends on what? Now again, they kind of give you a hint in the words, but it's not like the number of weeks changes because Jeremy is earning money. On the contrary, the amount of money, the amount of savings, depends upon how many weeks pass by. So now we can use the relationship and kind of set up our own numbers because they don't give us a bunch of numbers. They do tell us, hey, assume this is proportional. You saw that in the third sentence right there. So if it is proportional, what we can do is set up the very first ratio of $135 to 3 weeks. Now when we go ahead and divide that, we get $45 per week. Now, okay, 1 week, 45. And another 45 is going to be 90. And another 45 is going to be 135, and so on. So now that we've found the ratio, we can substitute it in as our constant of proportionality. And any X number of weeks that we choose, all we got to do is multiply that by 45. So in fact, here, they do give us a number. They want to know at 8 weeks. So once again, when I recopy the equation, I say, okay, where's 8 going to go? Well, because it's the number of weeks, we're going to substitute it in for X. Again, could we have just taken the table all the way down to 8? Sure. But anytime you want, I will race you. Well, okay, you need to stop talking, Mr. Cowan, because you're giving him a little hint for what we're going to talk about later. And so, once again, to review, the savings or dollars saved depends upon how many weeks he has been tutoring. We found the constant of proportionality, which was $45 a week, and we could even use that constant of proportionality to fill in other numbers in the table. Meanwhile, we also use that constant of proportionality into our equation, and then we use the equation substituting in 8 for x weeks to find that after 8 weeks, Jeremy would have $360 in savings. So in summary, I'm not going to say this out loud, but I've already given you some tips and then caught myself. How is writing an equation helpful? What advantages would it have in solving problems? So I'm going to leave you with that thought. When we get back to class, we will continue on with assignment number 6. And that's what I got, folks. Bring some questions and let's grow.